Okay, let me share my screen.
Before numerical, please discuss about priority encoders and multiplexers.
Okay, so I'll discuss multiplexer, and then priority encoder is like something is encoder. So you have to just given some priority, nothing like it's like something encoder. Maybe we'll discuss like one question that will be good in priority encoder. Okay, so suppose my screen is visible, right?
Yes.
Okay, two cross one multiplexer, right? So what is two cross multiplexer? So basically multiplex like choose what line should be selected, right? So suppose there is a this is a two cross one multiplexer. Suppose this is a select line, and they said the I0 and I1, right? And this is the Y. So one select line S and that Y. So on select line 0, I0 will be selected. When select line 1, I1 will be selected, right? So what will be Y? Y will be S bar I0 plus S I1. It's clear? 2 plus 1 multiplexer. Okay. Now we'll see 4 plus 1 multiplexer. Right. So what is 4 cross multiplexer? Select line will be 4 and output will be 1, right? So this is called 4 cross 1 multiplexer. Multiplexer, there will be two select line S1 and S0, right? So there will be 4 select line 1, 2, 3, and 4. I0, I1, I2, and I3. And there will be one output, right? So there will be S1 and S0, there will be Y, right? So when S1 and S0 both are 0, I0 will be selected. When S1 is 0 and S0 is 1, I1 will be selected. When S1 is 1 and 0, I2 will be selected, and 1, 1, I3 will be selected. So if you find the expression, it will be S1 bar, S0 bar, I0 plus S1 bar, S0, I1 plus S1, S0 bar, I2 plus S1, S0, I3. So 4 cross 1 multiplexer is clear for everyone.
Yes.
Yes, sir.
There are four inputs I0 to I3 and log to 4 is 2. So two selectors are there.
Yeah,
And Y is the output.
yeah, correct.
And then we are doing sum of products.
Yes, yes, correct.
Okay.
Okay, suppose another next question. Suppose we want to design 4 cross 1 multiplexer using 2 cross 1 multiplexer. So can you say how many 2 cross 1 multiplexer required? What is the minimum numbers of 2 cross 1 multiplexer required?
Log 4 will be 2, log 2 will be 2.
No, it will be more than 2. Not using 2, we cannot design 4 cross 1 multiplexer. So let
But
me,
then how do we think about that?
yes. So let me see the answer first, then we'll think about that. So how many records? First you have to divide by 2. 4 by 2 equal to 2. Then 2 by 2 equal to 1. So total numbers of multiplexer is required is 2 plus 1 equal to 3. And this syntax also said about that arrangement of the 2 cross 1 multiplexer, right? So first will be, there will be 2 cross 1 multiplexer, and output of that 2 cross 1 multiplexer will be fed into 1 multiplexer, like kind of that. This is 2 cross 1 multiplexer. So another will be 2.1 multiplexer. This will be select line, this will be select line, this will be I0, this will be I1, this will be I2, and this will be I3. And this, whatever the output, it will another 2 cross 1 multiplexer. Right, and this will be the another select line. Right. Yeah, this will be the IR. Now let's draw the truth table ones. So now, which will be the S1 and which will be the S0? Can you predict? So yeah, so you can suppose when 0 0. So suppose you want to select the I0. What you have to do? First you have to select this. So for select this, you have to put that 0. Right? Now among them, you have to select this line. So again 0. So this will be 0 0, right? Now suppose you want to select I1, right? So I1, to select I1, you have to put this will be 1. This will be sorry, yeah, I1. Then this will be 1. Then you have to put 0. So you can give this will be the S1 and this will be the S0. So this will be the
They didn't understand. Could you please repeat?
okay. Now arrangement is clear for everyone, right? Like how 2 plus 1.
Yeah, that is clear.
Okay. Now suppose you want to select I0. This will be select I0. So what will be the value of this select line? Let's read this, then it will be good. We have to put 0, right? So then I0 will be selected. Correct? Okay. You can see that when its select line is 0, then I0 is selected, right?
Mm-hmm.
When select line is 1, I1 is selected, right?
Correct.
So to select I0, we have to put 0 here.
Yes, I mean, first MUX, we should select 0.
Yeah,
Okay.
we do not care about the this select line. Now again, you have to select this.
Could you please use another color of your pen?
Yeah, yeah. Okay. So select 0, and if you want to select this, you have to again put here 0. Correct?
Mm-hmm.
So for I0, you have to put, suppose this is an I'm taking A, and this is a, and so okay. So this will be the both 0 0. So now suppose you want to choose I1, then this will be, suppose you want to choose this, then this will
Yeah,
be, this
1
will
0.
be,
Got it.
then this will be 1, right? correct?
Yeah, yes,
And again will be 0, right?
yes.
So for I1, it will be
0, 1.
1 0. This is 1 then 0, right?
No, I mean S1 we are writing, then S1 should be 0 and
No,
S0 should be 1, no?
no, I'm not telling about the which is S1 and which is S2, right? Okay, I'm only that selecting out the. I'm like you have to predict that which will be the S1 and which will be the S0, right? So for I0, if you want to select the I0, this will
Mm-hmm.
be 0 and this will be 0, right?
Both will be 0, yes.
Yeah. Now, if you want to choose I1, then this will be 1 and this will be 0. If you want to choose I1, then this will be 1 and after that again you have to choose here. So this will be 0, right?
No,
After that,
I1 we are selecting, so that select will be become turned on. So
uh,
I1 will come from there,
uh, so
and yeah, both of them are going as an input, so that state wouldn't change.
yeah. So
Okay.
now suppose you want to choose I2, then so this will be again 0
Okay.
and this will be 1, right?
Yeah,
0.
because 0 is exhausted there.
No, yeah. This will get I2 and suppose you want to choose this line. So you have to put 1, right? Then this is I0 and this is Y1, right?
Okay.
So you have to put here 1, right? And suppose you want to choose I3, then you have to put 1 also and 1 also. So if you observe, this will be S0 and this will be S1. This will be S1 and this will be not. This will be S0 and this will be S1. Both are 0 0 then
Correct.
1 1.
Yes, yeah. S0. Yeah, now it is correct.
Okay. Now suppose we want to draw 8 like you want to design 8x1 multiplexer using 2x1 multiplexer, right? So
7.
what is the numbers of required?
7.
Okay, so 8 by 2 it will be 4, 4 by 2 it will be 2, and 2 by 2 it will be 1, and it will be 4 plus 2 plus 1. And arrangement also like it's visual. First 4 2x1 multiplexer, then 2, then 1, right? So let design. So there will be 1 2 3 4 I0 I1 I2 I4 I5 I6 I7, then 2x1 multiplexer 2 required. So here 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 again 2x1 multiplexer. This is 2x1. This is 1. So and now if you want to choose the select lines, so the wall will be the S0 and this will be the S1 and this will be the S2. This is clear?
Yes. Thank you.
Okay. Now we'll solve some problem. Okay. Now tell me the solution. how many two input multiplexer are required to construct to the power 8 input multiplexer? Can you answer?
It is summation of 2 to the power 7 and 6.
Yeah. So to the power 8 by 2 to the power 2 to the power 7 plus 7 by 2 to the power 6 plus 6 by 2, it will be to the power 5. So it will be to the power 7 plus to the power 5 plus to the power 6 plus to the power 4 plus to the power 3 plus to the power 2 plus,
2 to the power 8 minus 1 to 50. How much is that? 255.
yeah, correct. So it will be 255 around. Okay. And now there is a sum like how many 2 to 4 line decoders with enable inputs are required to construct 7 to 128 line decoder. So here you have to do kind of 128 uh, divided by 4. So it will be what is the number we'll get?
32.
32 divided by 4, it will be 8. 8 divided by 4, it will be,
What is this 2 to 4 line decoder?
this is a decoder. I think there is, if you saw the lectures, 2 to decoder.
Oh,
So
yeah. 2 input and
a 2 input and 4 line decoder. And I think in the lectures, everything is given, right?
yes,
Decoder.
yes. Yes, yes.
So it will be 8 by 4, it will be 2. So it will be 32 plus 8 plus 2. So I think its answer is 32 plus 8.
40, 42.
So in that way, numerically we can solve, right? Okay, now, okay. So consider the circuit shown below. The function fx y z. So this is I0, this is I1, this is I2, this is I3, this is I4, this is I5, this is I6, this is I7, right? Now, uh, the function fx y z. So if you saw, this is 0, this is 1. So it is summation of,
137. 137.
yeah, summation of 1, 3, 7. But you can say there is a negation, right? Here it's negation again. So it will be summation of 0, then 2, then 4, then 5, then 6, right? Again negation. So it will be, right? And we are asking the 0 to 4, 5. So this will be the right answer. And if you write in the like
Because
POS,
it is a NOR gate.
yeah, because this is a NOR gate. And if you write in the POS, it will be 1, 3, 7. So this will be the correct answer. Okay, then, yeah. Okay, I think we have learned about the 4 cross 1 multiplexers. So consider the circuit shown below. The canonical product POS expression ABC. So you have to find the POS. So can you find that? What will be the POS here? Just try to solve. That will be good.
What is this C bar?
This is C and input is C and C bar is input. So what will be the F? Anyone solve?
So basically, there are four inputs and two selectors A and B,
Yes.
and which is giving the output FABC.
Yes.
So
Correct.
we create the truth table. So
Yes.
truth table will have f- four inputs. No,
Yes.
that will be for C bar. 0 and 1 will be always 0 and 1. So that
Yes.
is kind of fixed.
Yes.
So C bar will be 0, 1, 1, 0. That is also kind of fixed only.
Ah. Yes.
Two only. Correct.
Ah.
So now A and B, how to go about that?
Okay. So
Just construct the truth table for AB. So if you get 0, 0, then it's C. If you get 0, 1, then it's C bar, right?
okay. Okay. So if you like, what will the work getting Y? So if you see, for S1 bar S0 I0, right? So S1 bar S0, right? So it will be Y will be A bar, B bar, then C, then
No, no.
uh,
How do we create the truth table for this first?
so that 4 cross 1 multiplexer. See, if you see the 4 cross 1 multiplexer, this is S1 and this is S0. So I think already shown.
Mm-hmm.
So this is S1 and this is S0. So when it's 0, 0, I1 is selected, right? I0 is selected, right?
Hmm.
And when it's 0, 1, I1 is selected, correct? When it's 0, 1, means S1 is 0 and S0 is 1, I1 is selected.
Yes.
When it's S1 is 1 and S0 is 0, then I2 is selected.
Okay. So I2 and I3 are fixed here, like 0 and 1.
Yes, so 1, 0, then 1, 1, then I3 is selected. So if you find the expression, so if you S1 bar S0 I0, S1 bar S0, so when it's 0 means S1 bar S0 I1, and 1 means S1, S0 means bar, S0 bar I2, and S1 S0 I3, right? So here it will be A bar B bar C plus then 0, 1, right? So A bar B C bar plus A B bar 0 means 0 means it will be like null and plus AB. Up to that is clear.
Yes.
Now we'll get A bar B bar C plus A bar B C bar plus AB. We can write 1 C plus C bar. It will be anyway 1,
Yes.
right?
Yes. Yes.
A bar B bar C plus A bar B C bar plus A B C plus E B C bar, right?
Okay.
Correct. So we are
Mm-hmm.
getting SOP. So it will be 0, 0, 1. So SOP is 1, and this will be 0, 1, 0. It will be 2. This will be 2. This is 1, 1, 1. This will be 7. This will be 7. This is 1, 1, 0. This will be 6, right?
So
This will be
that
6.
is why it's options are in product, so option C.
So you have to find the product of sum. So this will be 0, 3. I think you got it, right? How to solve that type of problem.
Yes.
Okay, now consider the circuit shown below. The Boolean expression y implemented the circuit is. So you have to find the what will be the y Boolean expression, final Boolean expression. So maybe like I'll wait 1-2 minutes. You can just try to solve. That will be good. Anyone solve? Okay. So let's solve that question. Okay, so you can see that here is C and this is C. So what will give here? It will be C bar, right? Correct? Everyone got this? What is the symbol means? This is 2 cross 1 multiplexer. This is 2 cross 1 multiplexer. We have written like this. This is 2 cross 1 multiplexer. Okay. Now,
Why it is C bar?
okay, so you can see that one, if you see that 2 cross 1 multiplexer. So when it's selected 0, so when select line is 0, then it's I0, right? Correct?
Yes.
So in 2 cross multiplexer, I think this is 1 is given and this is C. 1 is 0 is given and this is select line 0. So if you expression like that, S0 is C bar and I0 is 1 plus C into 0. So it will be C bar, correct? You got this?
Okay, so inside 0 1 is there. That's why.
Yeah. Now here is 0, right? And this is 1.
No, in the diagram, within that trapezium, there is 0, 1.
Yes, this is 0 and
Okay.
this is 1 and this is 0. So
That is the input. That is
yeah.
the input.
Yeah.
So, now please go to the diagram.
Yes.
So here C bar we are writing because when input is 1, output is 0, and input is 0, output
No,
is
no.
1.
It is kind of a I0 IN, which are like, this is nothing. This is the input is 1. Input is 1 and
Okay.
1 and 0. Here is input 1 and 0.
Okay. So inside that 0, 1, nothing. It has nothing to do with that.
Nothing, nothing.
Okay. So when input is 1 and output is 0, and if the C becomes C bar, how still didn't get.
Okay, so this is the S and this is the Y, right? So this is 2 cross 1 multiplies. This is I0 and this is I1. This is select. When select line 0, which line will be selected? I0.
Okay.
When select line 1, which line will be selected? I1.
I1. Okay.
So what will be Y? S0 bar I0, correct?
Okay.
Plus S I1, correct?
Mm-hmm. Okay. Now I0 is 1 here.
Ha,
Understood.
ha. Now you got it, right?
Yes. Yes.
Now here we are getting C bar and here we are getting C. Okay. And now here is also getting C bar and here getting C. Now what will be the this expression? This will be B bar C plus this will be B C bar,
This
correct?
becomes XOR. B is or C.
Yeah, B dot C. Here, here what will get?
Below also same input will
Yeah,
come.
correct. So this will be not same input. Will get difference. I think this will be like B bar C bar plus BC.
Yeah, which is
Correct.
same like B is or C.
It's B dot C bar, right? Not
Sorry, B is or C whole to the power bar. Correct.
correct. So now here this is the input. So Y what will get? It will get A bar B dot C plus A B dot C bar.
Yeah, A or B is or C.
Yeah. So how will feel this question? Like this question will this type of question will be come in the OPP.
No, I was not able to understand why there is 0, 1 within the trapezium.
0 1 is like a
Inside, I'm saying.
okay. So inside what happened na? Suppose this is a 2 cross 1 multiplexer. So some book are they follow this is I0 and this is I1. Right. So you're following this is initially this is I0 and this is I1, right? So which will be the 0 and which will be the 1? So that's the thing inside.
Okay. Okay.
So if it is 0, then this will be the I0 and this will be the I1. And if it is like ulta,
So
like
if it is swapped, then how should we take?
this will be like kind of same. Kind on S0 will be this. If you draw
Okay,
the
so upper one be like on and lower one be off.
yeah, correct. Okay. Now let's solve this question. Consider the we have input A, B, C and their complement. So we have an input A, B, C and their complement. Find the minimum numbers of 4:1 multiplexer required to implement the above logic diagram. So what is the minimum numbers of 4 is to 1 multiplexer required to implement the above logic diagram? So what you have to do? First you have to find the app. Then after that, find how you can design the circuit using 4 is to 1 multiplexer.
ABC plus A naught B naught C naught. What is that?
So, what is the app? App will be anyone?
It will be ABC
A, B, C,
plus A bar, B bar, C bar,
A bar, B bar.
B bar, C bar.
Okay. Now can we implement this using 4 is to 1 multiplexer?
Is this exclusive NOR, sir?
No, this is not exclusive now. Okay, suppose you want to design. So this is the 4 plus 1 multiplexer is there. Right. Now you can see that A bar, B bar is given and AB is given, right? So we can choose the select line anything. So suppose you are select line AB, right? So AB, A bar, B bar, C bar. So if you put here C bar, we're getting A bar, B bar, C bar, and ABC. So if you are putting ABC, we are getting C, and another things we are putting 0. So you'll get Y equal to A bar, B bar, C bar plus ABC. Everyone got it?
Yes, sir.
Okay.
No, how to think like and come up with this diagram.
Okay. So that you can say that
Okay, if I would have written like A bar, B bar, C bar, and ABC, then these two would have flipped
yes,
C and C bar. Okay,
yes,
okay, understood.
yes. So I think most like whatever the all the like if you you can able to now solve all the graded assignment solution, right? So if you have any okay, now there is one question left. Consider the circuit decimal BCD encoder given below. The OR gate A2 fails. What with the output terminals follows high? How many inputs code will be affected due to this? Okay, so this is the encoder BCD encoder. Anyone? How to solve this question?
What the question is saying? I mean, this A2 or get A2
Yeah,
fails.
or get A2 is fails. So how many
Now,
uh,
what does it mean? It fails.
fails means suppose it's maybe like we can say that it's maybe damage due to some reason or something.
Then what output will come from A2?
It will be like nothing.
Okay, so whatever we are sending to A2, nothing will come out of it.
Yeah, so you have to say what, like how many numbers will be affected.
A2 is getting inputs from. No, it is saying A2 fails with the output terminal as always high. Does that mean
Yes.
A2 will always be 1?
Yeah, after the failing, it will be always be one.
Then in the truth table, upper half will go, A2 will always be 1. Correct?
Yes, correct, correct. So you can see that there are 1, 2, 3, 4, 5, 6 will be affected. Correct.
Correct.
So this is the. So I think we got it.
Now, how many output codes means what?
Yeah, correct.
So 6 rows of the truth table will be affected.
Yes, correct.
Now, what is the meaning of this?
Okay, so suppose if you want to design the BCD encoder, right? So you can see that BCD encoder means like it will like encoded the that BCD like 0, 1, 2, 3, 4, 5 like 0, 1, 2, 3, 4, 5 into the BCD. Like if you say the BCD display, right?
What
So
is BCD?
BCD binary code decoder.
Okay, okay.
So if it is 0, so if it is like 0, then all will be the 0, right? So if you see, if it is 0, all will be the 0, and this if it is 1, then A0 will be 1. If it is 2, Y2 is 2, that A1 and A0 will be kind of that. If it is 3, Y3, then A1 and A0 will be 3. If it is 4, then it will be like that, right? Now if you want to you can see that.
So basically it is saying that there are 10 inputs and only one is on at a time. So that is
Yes,
why
correct.
there are 10 rows. Okay.
Yeah, correct, correct.
Okay.
And we are
So
encoding like there will be like 9s 0 to like 9 will be there. So then if you are
0 to
set,
9 is 10,
yes, correct.
and that is giving us 4 encoders.
Yeah, 4 input.
So which MUX it would be?
Okay, so suppose this is the okay 0, 1, 2, 3. So binary. So if you select this line, then 0 will be display, right?
Yes.
So suppose there are 4, 1, 2, 3, 4, 3, 4. So 0 will be display when all the things will be 0, right?
Yes.
Suppose is 1, then this it will be converted into the binary, like whatever the binary is 1 and 0, right?
Correct.
Sorry, 1 means 0 and 1, right?
Yeah, last will be 1. Yes.
Yeah, and 2 means 1 0.
Yes.
So that's why you can see that 1 0. If it is selected 2, then 1 0. If it is selected 3, this is 1 1.
And for 9, it will be like, okay, okay.
Right? You got it?
Yeah, I got it. But I was thinking in like MUX, which MUX it will be and how many?
It's not a multiplex, it's encoder.
Oh, sorry. Correct.
Right? Now we got it.
Yes, got it. Thank you.
Now, suppose you want to draw the A1 circuit. So you can take the SOP, right?
Yes.
A0, so you can see that when it is A0 is 1. So for Y1, then you have to choose the Y3, then Y5, like that. So you can just SOP you are taking, right?
Yes.
So this is why we can design the binary code decoder. Right? Now, if A2 is fail, then how many A2 is fail and output one terminal is always high, then how many rows will be affected? Right? So you can see that there are 6 rows affected.
Correct.
Correct. So
Yeah, they will not be behaving as required.
yeah. Correct. So any doubt in which 4? So I think next week, I think quiz is there, right? So next week there will be one revision session. So say week 1 to week 4, if you have any doubt in that session. So any doubt?
Yeah, okay. That week 5 deadline is 3rd March.
Uh, yeah, 3rd March. Or if you want, like you will conduct one more session, because what happened now? Week 6 generally like kind of there is no graded assignment, and kind of you can like we are hoping all things will be practiced in circuit first in week
So,
5.
so I don't know whether there is any mock kind of thing, but if you can help us with, uh, I mean, mock paper for quiz.
You can solve a previous year term paper. That is
Yeah, that definitely will do. But
yeah. So
in addition to that,
what will you like will give as a mock in portal previous year term paper.
okay, understood.
That will be good. You can practice in the portal also.
Okay, that is good.
Yes. Okay. So any doubt?
So, I mean, when can we have? I mean, will you be conducting one revision session or maybe 2?
One revision session will be, I think, sufficient.
When will that be? Same
Yeah,
Thursday.
next Thursday, 7 to 8. Maybe extend like up to if you
Understood.
if you have more question, maybe like 7 to 9.
Then if you can configure the mock in the portal before that, that will help.
Yeah, I'll configure all those.
Okay, thank you.
Yes. Okay.
So,
maybe-
one more thing I would like to know, where is this live sessions being recorded? Like, where is this folder being uploaded to?
we have all the links and in the calendar itself.
Oh, okay.
So you can check the calendar and you can go to the live session link. And Bimlesh, are you like, I think calendar is visible,
Yes,
right?
it is visible.
But sir, it's visible, but the video or anything, all these things, it's okay. It's uploaded in YouTube. Okay.
Yeah, uploaded. Yes. So
Okay,
maybe
sir.
like after that recording is coming, so maybe today night or tomorrow morning we'll upload in the YouTube and update it in the calendar.
Okay, sure, sir.
Yes, previous recordings are available.
Yes. Okay. So Gavind, you are silent in the whole class. Do you have any doubt or do you want to ask anything?